So today's question is remove nth node from the list, right? So this is a very easy question and it's pretty self-explanatory. First, let us look at the problem statement, which is very small in itself. So here goes the problem statement. Given the head of a linked list, remove the nth node from the end of the linked list and return its head, right? So basically, what we are required to do is that we are given a number n, and we are supposed to remove the nth node from the end of the list and basically return the list after removal of the node. A very simple problem. Not go. I'll not draw a diagram and like explain you what it means because this diagram which is given here in example one is pretty self-explanatory. You can see that there is a linked list which has these four elements. There are these five elements in fact which are there. 1, 2, 3, 4, 5. We want to remove the value of n is 2. That means we want to remove the second last element, which is the fourth, the node with the value 4 here. And then once we remove that, then our remaining list would be 1, 2, 3, 5, right? Which is pretty self-explanatory. Now let us look at the code and how it is done. So we have two inputs. One is the head of the linked list, and one is the n number n, which it signifies the I mean the basically value from the end. Which you're about to remove. Okay, so in order to solve this, you have a very simple utility function called find the length of the linked list, which basically returns you the length of this current linked list, right? Because explicitly that length cannot be found by just the head pointer. We need to traverse the entire linked list to find out how long the linked list actually is. So here we have this function, find the length of the linked list. We take the head as input, we initialize current to the head, and then we keep a counter, and then we basically move to the end of the list and increment the counter each time, and we return the counter that would basically return us the length of the list. This is the code of this. It is pretty easy to understand. I don't think I need to explain this any further, so I'll move forward. There is this special case which we're handling here when length is equal to n. That means we are trying to remove for example, we are trying to remove the fifth node from the end, and the length of the list is itself 5. In that case, we are basically trying to remove the head node, so we must have to return head dot next, because that is our new head if our head is removed, right? And then of if length is less than n, we return a null pointer, because that is not possible. We can't basically have length, we can have a n which is greater than the length of the linked list. So that this is also pretty self-explanatory. I'll not go into the details of this. These are just two base conditions, right? And then we have or pardon me, this is just a special condition, and this is one, you can call it as a base condition. So now moving forward to the main small code snippet. So we initialize current to the head. We have a previous pointer. I'll come to why do we need to have a previous pointer. Then we basically traverse from 0 to length minus n. So basically we traverse length minus n steps. Why do we do that? Because we need that to come to the node which you're about to remove, right? Given the definitions of n length, right? And then we have a previous pointer which is the current, and the current is moved to current dot next. Why is it so? Because after the end of this iteration, current would be at the node which has to be removed, and previous will be at the net node before the node which has to be removed, right? So in order to modify the list, we will have to point the previous pointer next to current's next pointer, which we will be doing here, right? Which we'll be doing here in this line. And then obviously this is not required anyways, but you can do this. We can point the current dot next to null pointer. This is why it's not required, because anyways when we return the head, since our pointers already rearranged here, so after the previous node, the traversal of the linked list will move to the current's next node anyways, and the answer would anyways show up to be correct, right? So we don't have to do this step. Let me give you a demo that it is not really required. Let me comment this out and maybe submit this again, right? So you can see it's not really required, so okay, this can be skipped, and then we return the head. So with this I come to the end of explaining this problem. I hope you understood this problem. I see you in the next video. Thank you. Bye.